What's going on, everyone? Don here with the Physics Instructional Resource Team, and I've got another demonstration here for you today, and we're going to talk about angular momentum and torque, and this bicycle wheel right here, which we've seen before in a previous video. Now, we remember if I add some rotation to this bicycle wheel, there's some angular momentum on it that's defined by the right-hand rule. And so that right-hand rule is if you curl your fingers in the direction of the rotation like so, then the direction of the angular momentum is in the direction of your thumb. So it's out across the handle here. And if I were to spin it the opposite way, it would then be in the opposite direction towards me. And that's the way I'm going to spin it for this demonstration. Now, a different way we can apply angular momentum to this system, instead of with my hand on the wheel, is through the force of gravity. And so we're going to move this hook here, and let's say I put this handle on the hook and I let it go. What's going to happen? Well, it'll just fall straight down like that. I'm trying not to let it hit the table just because it's going to be loud, but right, it'll fall like that. And what gravity is doing is adding a torque to the system. If you notice, it's rotating around this axis, which means if we do the right-hand rule, it rotates like this, then the angular momentum is being changed in the direction of the spokes. Now, what if we were to combine these two phenomena, where we have angular momentum in the direction of a handle, either this way or this way, depending on how I spin it, and then we have some torque from gravity acting along the spokes, 90 degrees away from the handle. What should happen? And so we'll do the experiment. I'm going to go ahead and put that handle there, and we should see the angular momentum is out along this spoke, but the gravity is out, along that handle, and the gravity is acting along the spokes. And so it wants to continually move towards that force of gravity, that torque from gravity. And you can see as it slows down, it's tilting a little more. That effect of gravity is becoming a little more evident as friction takes speed out of the wheel. And this is called precession, where some torque is making a rotating object rotate around another axis. And this has implications for large and small scale things. Obviously, it works on this bicycle wheel. It's how we describe tops, right? It precesses around that central axis, but it's also how we describe how the Earth rotates. The Earth itself precesses around an axis. And so this is just a little bit more detail on angular momentum and how we can interact with it with torque. And so this is Don. This is the bicycle wheel precession, and I'll see you next time.